Here's a lesson on ratios, rates, and proportions. In part 1 of this lesson, we'll start by looking at ratios. A ratio compares two values of the same type. It tells you how much of one thing there is compared to another. So for example, in this diagram here, where we have 2 circles and 4 squares, the ratio of circles to squares we would write like this: a 2, then a colon, then a 4. Since we wanted the ratio of circles to squares, the number of circles has to come first in the ratio, and the number of squares would have to come second in the ratio. And when writing a ratio, those numbers would be separated by a colon. From the diagram, we can tell that there are 6 total shapes, and we can tell just from the ratio of the total number of objects by adding the 2 numbers in the ratio. 2 plus 4 is 6. So notice this ratio has 6 total parts. And just like fractions, ratios can actually be simplified by either multiplying or dividing both parts by the same value. A ratio is considered simplified if there is no equivalent ratio with smaller whole number values. So for example, our ratio of 2 to 4 could be simplified by dividing both parts of that ratio by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2, so the ratio of 2 to 4 can simplify to 1 to 2. These would be considered equivalent ratios. And now let's look at our first example, where we encounter a problem where ratios are often used, and that's in recipes. In example 1, it says a recipe for pancakes requires 3 cups of flour, 4 cups of milk, and 2 eggs. So I've written the ratio of flour to milk to eggs as 3 to 4 to 2. But it says we only have 1 egg left, so we have to adjust this recipe so that its proportions are equal. So if we only have 1 egg, we have to figure out what would be the amount of milk and what would be the amount of flour to keep the proportions exactly equal to the ratio we have written above, 3 to 4 to 2. So I'll put in variables for the amount of flour and the amount of milk. I'll call them x and y. And now we need to solve for those values of x and y. If I want to solve for the amount of milk in my adjusted recipe, well, I know the amount of milk to eggs, so y to 1, has to be equal to the ratio of the original recipe, which was 4 to 2. And I know these numbers are simple enough, you could probably figure out what value of y keeps this ratio equal. But it would be useful often, when the numbers aren't this simple, to rewrite these ratios in fraction form. In fact, it's often common to convert ratios to fractions to help solve for a missing piece of information. So I could write this ratio of y to 1, I can write it as a fraction of y over 1. And that would be equal to the fraction of 4 to 2, so I'll write it as 4 over 2. And y divided by 1 would just be y, telling me that y would equal 4 divided by 2, which is 2. So y would equal 2. So the new recipe needs 2 cups of milk. And now let's also solve for the amount of flour. Well, the amount of flour to eggs would be x to 1, and that would have to be equal to the ratio that's in the original recipe for flour to eggs, which is 3 to 2. And now let me convert both of these to fraction form. X to 1 I can rewrite as x over 1, and 3 to 2 I can rewrite as 3 over 2. X divided by 1 is x, and 3 divided by 2 is 1.5. So the new recipe needs 1.5 cups of flour. So let's summarize this in a final answer. The original recipe's ratio of flour to milk to eggs was 3 to 4 to 2, and the new recipe, which has an equal ratio but only includes 1 egg, we figured out would be 1.5 to 2 to 1. And remember, in these ratios, it was flour to milk to eggs. So the new recipe, which I've highlighted, needs 1.5 cups of flour, 2 cups of milk, and only 1 egg. So now that you know how to work with ratios, let's move on to the next part of the lesson where we look at rates. Rates compare 2 quantities of different types. So we're going to have different units of measurement. It expresses how much one quantity changes with respect to another quantity. So some examples of rates would be a speed such as 60 kilometers per 1 hour, cost like $3 per 1 item, heart rate, which could be 6 beats per 1 minute, or internet speed, which is 1 gigabyte per 1 second. Notice in each of those we had 2 quantities. Like in internet speed, it was gigabytes and seconds, or gas efficiency was kilometers and liters. We're always comparing how one quantity changes with respect to how another one changes. And in each of these examples I gave you, I actually gave you a unit rate. which is a comparison of quantities in which the second quantity is 1. Right? In each of those examples I gave you, the second quantity was 1. It was per 1 hour, or per 1 item, or per 1 liter, or per 1 minute, or per 1 second. Those are all unit rates. Rates aren't always given in unit rates, but it's often useful to convert them to unit rates to get a good understanding of the relationship between the quantities. Which is why in example 2, we're going to be doing exactly that. Example 2 says calculate the unit rates for each of the following rates. 2a gives us a rate of $10 per 4 chocolate bars, but we want a unit rate, which means how much money does it cost per 1 chocolate bar. We want the second quantity to just be 1. So to find the cost per 1 bar, I'm going to write my rate as a fraction. And now what we want to do is find the unit rate, meaning we want to know the cost per 1 bar, but right now it gives us the cost per 4 bars. So I need that 4 to be a 1. So I would have to divide it by 4. And I can do that as long as I divide the top by 4 as well. 10 divided by 4 is 2.5, and 4 divided by 4 is 1. So now you can see that this is a unit rate. It is $2.50 per 1 bar. It's a unit rate because the second quantity is 1. So we'll state the unit rate as $2.50 per bar. And you may notice a shortcut for getting the unit rate if we had have just taken the original fraction, 10 over 4. And remember, a fraction is just a division question. This bar is just a division line. If we had have just done 10 divided by 4, it would have given us 2.5. And now let's go ahead and do part B, where we have a rate of 5 kilometers per 25 minutes. To change it to a unit rate, I want to figure out how many kilometers per 1 minute. So I'll write my original rate as a fraction, 5 kilometers divided by 25 minutes. And then I want this 25 minutes, I want it to be per 1 minute. So I'll have to divide top and bottom of this rate by 25. 5 divided by 25 is 1/5, or 0.2. And then 25 divided by 25 is 1. This is now a unit rate. It's 0.2 kilometers per 1 minute. The second quantity is now 1. So I'll write the unit rate as 0.2 kilometers per minute. And you may have noticed at the beginning of this question, I called this a speed. And that's because we did a distance divided by a time, which calculates speed. And also, we could have jumped right from here where we had 5 over 25 to our unit rate just by doing 5 divided by 25, and it would have given us 0.2. And let's see how we can apply this knowledge in example 3, where we figure out the better buying option for ground beef. To figure out the better buying option, we want to convert both option A and option B to unit rates. So we can see how many dollars it is per 1 kilogram, right? We want these second quantities of both of them to match, so that's easy to compare them. So we might as well make it a unit rate where both the quantities are 1. So for option A, it's $8.49 per 0.45 kilograms. So to find the cost per 1 kilogram, I could write the rate as a fraction. And then if I just do the division, if I do 849 divided by 0.45, I would figure out that's equal to 1887. And then what units go with this? Well, when we did the division, we did dollars divided by kilograms. So what we calculated is how many dollars it is per kilogram. And now let's find the unit rate for option B to see if it's more or less per 1 kilogram. I'll write the original rate of 34.81 per 214 kilograms as a fraction. And then if I do 34.81 divided by 2.14, that equals 16.27. And since we did dollars divided by kilograms, that would be the amount of dollars it is per 1 kilogram. So notice this is a smaller unit rate, so it costs less per kilogram for option B. So the better buying option, assuming they're the same quality of ground beef, would be to get the cheaper one. And now let's move on to part 3, where we look at proportions, where a proportion is just an equation that states that two ratios are equal. So for example 4, it says that Callum can type 100 words in 4 minutes. How many words can he type in 10 minutes? So let me set up two rates that are equal to each other to help me solve this problem. I know he types at a rate of 100 words in 4 minutes, so I'll write that as a rate. And I'm interested in how many words can he type in 10 minutes. So I'll set this equal to a rate where I don't know the number of words, so I'll call it x. I'll say x words in 10 minutes. Now, assuming his rate of typing stays constant, I know that these two rates would be equal to each other. And now to solve for x, there's lots of different ways using algebra to solve for x here, but I think what might be easiest, if we change on the left to a unit rate, by doing 100 divided by 4, I would figure out that his rate of typing is 25 words per minute. So if he can type 25 words per 1 minute, how many words per 10 minutes? Well, we would just have to multiply that unit rate, what he does per 1 minute, by 10 to figure out how much he's going to type in 10 minutes. And algebraically, that's exactly what would make sense. We would just multiply both sides by 10 minutes to isolate x. On the right, the 10 minutes cancel. On the left, the minutes cancel. And I'm left with just 10 times 25 words, which is 250 words. So Cal can type 250 words in 10 minutes. Now let's go to example 5, where we use proportions to convert between different units of measurement. Example 5 says to use this unit conversion chart to help convert each of the following. Part A, we have to change 3 inches into centimeters. So the rate of 3 inches to x centimeters, we don't know the amount of centimeters, would have to be equal to, well, let's look at the relationship between inches and centimeters. So I can set this equal to the rate of 1 inch per 2.54 centimeters. Well, if in 1 inch there's 2.54 centimeters, then in 3 inches there would be 3 times that amount of centimeters. But how can we show that algebraically? When you have a proportion where we have rates equal to each other like this, we can use the method of cross multiplication. So I can do 3 times 2.54 and set that equal to the product of x times 1, which is just x. So this would give me an answer of 7.62 is equal to x. This method of cross multiplication can only be used when we have 2 rates set equal to each other. We find the product of the numerator of one side with the denominator of the other side and set that equal to the product of the other denominator and numerator pair. And that allows us to easily isolate for x. So now we figured out that 3 inches is 7.62 centimeters. Part B, I have to convert 3,500 meters to kilometers. So I'll set up that rate of 3,500 meters to x kilometers. And I know that's equal to, if I look at my table, every 1 kilometer is 1,000 meters. And now since I set up this rate as meters to kilometers, I have to do the same for the other rate. So I'll have to set it up as 1,000 meters to 1 kilometer. The units in the top have to match and the units in the bottom have to match. And now I can use the method of cross multiplication. That product, 3,500 times 1, would be equal to the product of x and 1,000. And now to isolate the x, I'll have to divide this 1,000 to the other side, which gives me a final answer of x being equal to 3.5. So 3,500 meters is equal to 3.5 kilometers. Part C says to convert 1,000 ounces to pounds. So the rate of 1,000 ounces to x pounds should be equal to, if we look at the conversion table, every 16 ounces is 1 pound. Doing the cross multiplication, I have 1 times 1,000 equal to x times 16. Then I'll have to divide this 16 to the other side, because on the right it's multiplying by 16. On the left I have to do the inverse, which is dividing by 16. And 1,000 divided by 16 is 62.5. So 1,000 ounces converts to 62.5 pounds. So in doing unit conversions, these proportions are helpful. You set up the 2 rates equal to each other, then you can solve for the one unknown using algebra. And now let's move on to the next example. Example 6 says, what if we had 60 shapes that had a 1:2 ratio of circles to squares? How many circles and how many squares would there be? So this question gives us the ratio of circles to squares, but it doesn't tell us how many circles or how many squares there are. It just gives us the ratio of circles to squares. What it does tell us is how many total shapes there are. And we need to be able to use that information to help us solve for how many of those 60 are circles and how many of the 60 are squares. Let's start by finding how many of these 60 shapes are circles. To be able to figure out how many of the 60 are circles, I'm going to have to write a ratio, not of circles to squares, because I don't know how many squares or circles there are, but I'm going to have to write a ratio of circles to total shapes. Writing the ratio in this format is going to be useful for this question because I'm going to be able to write a proportion. I'm going to be able to write 2 ratios equal to each other. I know there's 60 total shapes, so I can put 60 in for that part of the ratio, but I don't know how many circles. So I'll use x to represent the number of circles, so x to 60, and that would be equal to, based on this ratio of circles to squares being 1:2, I know the ratio of circles to total shapes should be equal to 1:3. Right? If we look over to the right here in this note, In a 1-to-2 ratio, the total number of parts is just equal to the sum of the two numbers in the ratio. 1 plus 2 is 3, so there are 3 total shapes in that ratio. And I should also note we're using ratios here, not rates, because we're dealing with circles and squares. Those are both shapes. Those are like objects. And what I can do now is I can solve for this value of x by first writing these ratios as fractions. And now I just have to solve for what value of x makes this proportion true. A couple ways we could do that. I noticed to get from 3 to 60, I have to multiply by 20. So if I do that same operation here, I would see that this x would have to be 20 to keep those ratios equal to each other. Or if you'd rather use an algebraic method, to isolate this x, we could just multiply both sides of this equation by 60. On the left, they cancel, leaving us with just x equals 1/3 times 60. That just means divide 60 by 3, which is equal to 20. So we just solved for x, which remember in our ratio was the number of circles. So of the 60 shapes, 20 of them are circles. And now we also have to solve for the number of squares. So I'll set up a ratio of the number of squares to total shapes. I'll use the variable y to represent the number of squares. So y to 60, right? There are 60 total shapes. And then based on the ratio of circles to squares having to be 1-to-2, I could set this y to 60 ratio equal to, well, in the 1-to-2 ratio, the 2 is the number of squares. So I could set it equal to 2 to 3. Remember, in a 1-to-2 ratio, add 1 and 2 together, and there are 3 total shapes in that 1-to-2 ratio. So using this proportion, I can solve for y. It would probably be useful to write it as a fraction first, and then algebraically, to isolate this y, multiply both sides by 60. On the left, they cancel, and we figure out that y is equal to 2/3 of 60. Well, 2 times 60 is 120. Divide that by 3, you get 40. So of the 60 shapes, 40 of them are squares. And hopefully you can see that this is the right answer. If we have 20 circles and 40 squares, that ratio of 20 to 40 is equal to the ratio of circles to squares the question gave us, the 1-to-2 ratio. Right? If I divided both the numbers in that ratio by 20, I would get 1-to-2. So those ratios are equal. And now let's move on to part number 4, where we look at percentages. It says that a percent is an amount out of 100. This symbol, this percentage symbol, means per 100. So for example, 25% means 25 out of 100, or as a fraction, 25 over 100. So let's try example 7 that says convert the following percentages to decimals. Well, remember 30% just means 30 out of 100. So I can write that as a fraction, 30 divided by 100. And then to get the decimal value, you actually just do that division. Do 30 divided by 100, and that equals 0.3. Then for 58%, that means 58 per 100. Writing that as a fraction shows me to get the decimal value, I just do that division. 58 divided by 100 is 0.58. And now let's go the other way. Example 8 says to convert the following to percentages. Well, right now, this 0.2 as a fraction would be 0.2 over 1. Now I want to know what would that be equal to if I had it over 100. So what value over 100 has that same rate? I can just multiply both sides by 100. On the right, they cancel. And notice on the left, I just have 0.2 over 1, which is 0.2, being multiplied by 100. So to get x, all I'm doing is 0.2 times 100, which gives me 20. So we've just figured out that 0.2 is equal to 20 over 100, which we can write as a percent as 20%. Part B is a little bit different because in part B, it's already a fraction. It's 7 over 10. And what I want to do is change that to a percent. So I need it to be some number, I'll call it x, over 100. Well, 7 divided by 10 is 0.7. And then to isolate x, I'll multiply both sides by 100. On the right, they cancel. And on the left, I have 100 times 0.7, which is 70. So x is equal to 70. So to get 7 over 10 into a percentage, I know that 7 over 10 is going to be equal to 70 over 100. And therefore, I can write that as 70% because it's 70 per 100. So basically, to convert any value to a percentage, change it to a decimal value. So like 7 over 10, change it to a decimal by doing the division, getting 0.7, and then just multiply it by 100. And now let's move on to one last example, example 9. where a new Bauer Twitch hockey stick is $430. Pro Hockey Life is advertising a sale where the stick is 25% off. How much is saved on the stick? Well, let's figure out what is 25% of $430 to figure out how much is taken off. Well, 25% means 25 per 100, and to figure out what 25% of 430 is, I can set up a proportion. I'll set 25 over 100 equal to some unknown amount per $430. 25 divided by 100 is 0.25, and then isolate x by multiplying by 430 on both sides. And you can see to get x, which is what 25% of 430 is, we're just multiplying 430 by 25% as a decimal, which is 0.25. And 430 times 0.25 is $107.50. So the stick is discounted by $107.50. And now hopefully you notice a shortcut to finding a percentage of a number. Instead of having to set up a proportion, you can just find a certain percentage of a number by multiplying the number by the decimal value of the percentage. So all we had to do for this question was multiply 430 by 0.25. And now part B says, what would be the sale price of the stick? Well, to get the sale price, I just have to take the regular price and subtract the discount. So the regular price was $430, and I have to subtract the discount of $107.50. And that gives me a sale price of $322.50. And now I put a note on the side that if we didn't already know the discount that was to be subtracted, it would have been faster to just figure out what 75% of the original price was. Right? If we do a discount of 25%, that means only 75% of the original price remains. And I know to figure out what 75% of a value is, I just multiply the value by the decimal version of 75%. So I would do 430 multiplied by 0.75, which gives me 322.50. And lastly, let's do part C. What will the total cost of the stick be, including 13% HST? So total cost would be equal to the sale price plus whatever 13% of the sale price is. Now, I know the sale price was $322.50, and then to figure out what 13% of that sale price is, we don't have to worry about setting up a proportion again. We figured out that to figure out what a percentage of a number is, we just multiply the number by the decimal version of the percentage. So the decimal value of 13%, just divide it by 100 to get 0.13, and I multiply that by the sale price of $322.50. And that figures out what 13% of $322.50 is. And it turns out that that is $41.93. And then if I add that tax to the sale price, I get a total cost of $364.43. So that's it for this lesson. Make sure you go to jensenmath.ca and get a copy of the practice questions that go along with this lesson. Jensen Math!